you will learn about various authentication concepts and methods, along with some basic security principles used to manage accounts. This chapter closes with a comparison of some access control models. All right, let's start with fundamental concepts of authentication. Authentication proves an identity with some type of credentials, such as a username and a password. There is authentication, there is authorization, and there is accounting. Those three major concepts are, we call them sometimes triple A's, AAA, because they work together with identification to provide a comprehensive access management system. Users are granted authorization to access resources. It could be a file, it could be a printer, or it could be anything that can be accessed. They have to be granted authorization. How we grant them this authorization, it is based on their proven identity. So the main thing here is, how do they prove their identity? That's we will discuss what are the types of credentials, or how do they authenticate, and what kind of authentication types are there. We will also go deep into accounting methods. How do we track user activity when they access it, who accessed it, what time it was accessed? All this has to be, there must be some kind of accounting method. And also there is an important concept called audit trail. It allows security professionals to recreate the events that preceded a security incident. Let's say somebody accessed the file and he deleted the file, or removed the file, or altered the file. There must be some kind of audit trail to prove that person did that particular change or incident. Then we need to look into the authentication factors or types of authentication. There are about 5 different kinds of authentications. Those are major authentication types. We call them authentication factors. Sometimes we use just one authentication type. Sometimes we can use more than one. We called it a multi-factor authentication. So the simpler one we are commonly used to authenticate to a system is what we call something you know, such as a password or a PIN number or a personal identification number. You go to your computer, you type your username, and to get access you have to type some kind of a password. This is called something you know, the simpler one. And then we can use what we call something you have. All right, here we have the authentication factors or types. The easiest one, the most commonly used, is called something you know. This is something like your password. You go to a computer system, you type your username, and to get authenticated, it demands that what is your password? You need to know your password, or sometimes you need to know your personal identification number or a PIN. So this is the most common one, and currently it's considered to be the simpler authentication type. Then we do have what we call something you have. Something like a smart card or a USB token. This is getting more popular. Most civilian and federal organizations, they do have something called a PIV card, where it has a chip on it, and you have to type your password. That's not sufficient. Additionally, the system asks you something you have. You have to present your PIV card. On top of that, we do have something called something you are, which is common. Those of you who have those modern cell phones, you are familiar on how to use your fingerprint. The fingerprint is your biometric identity, something you are, such as your fingerprint or any other biometric identification tells who you are. So basically that is the third one. And then we do have somewhere you are. That is particularly this is your using your location, using a geolocation technology. So you have to be somewhere. As soon as you are somewhere, that system allows you access. If you're not at that particular location, it doesn't allow you access. This is what we call something you are. And then the last authentication factor, or the last type of authentication type, is what we call something you do. This is also currently very popular among cell phones. You go bring your finger and type some kind of gestures. So the computer screen is so smart, they capture your gestures. So something you do is that's as simple as a gesture, and it could be as complex as the system identifying who is using that keyboard by measuring the speed of the keyboard. So this is what we call authentication factors. Then let's talk about password complexity, because password is one of the simplest authentication type we use to get authenticated. There must be a strong password. What we call a strong password is it's a mixed characters with at least 14 characters. That is what we call a strong password. Anything less than 14 characters is not considered to be a strong password. However, there is a terminology called complex password. Complex password uses a mixture of character types. What it does is you can use uppercase, lowercase, special characters, numbers, you know, different kind of character types. You know, it is kind of difficult. So basically what we call complex password doesn't necessarily mean, you know, a strong password. So those are two different concepts. A strong password is mixed characters with at least 14 characters, but complex password is the more difficult mixed character of types. What happens when you make passwords too complex? People tend to write their password on a paper, and sometimes they write it next on a notebook next to their keyboard. Sometimes they leave it inside their office, and intruders might be able to find it. So more complex equates to less security. Let's see about how we create, you know, a strong password, and how can we crack them, how can we break them. You know, the combination of different characters in a password makes up the key space, and you can calculate the key space, you know, with a simple formula called C to the power of n, where C is the number of possible characters used. For example, in English, we do have 26 characters, and n is the length of the characters. Let's say you use a 6-character password. What it means is that 1 is 6, which is the possible characters within that spelling alphabet, raised to the power of 6, which is equal to 308 million different passwords. So a hacker or an attacker, to break into your password, he must try 308 million different combinations of the letters. So basically you think it is a very big number, but it is not. It can be break with, you know, hackers with you know, most recent technologies, they can crack it in less than, you know, 10 minutes. And then if you make it a 10-character password, which is 26 to the power of 10, it goes to 141 trillion. Again, with the help of, you know, powerful computers, they can break it in less than 2 hours. So basically, the strong password is currently considered to be at least 14 characters. So when we continue, let's continue about discussion on a password. There is a password expiration, passwords to expire. There is a password recovery, meaning when you forget your password, there must be a way to recover your password. There is a service called Forgot Password Service. There is also a password history. When you log into some computers, sometimes the computers do not allow you to reuse your password. So password reuse is prohibited, saying that, hey, they count sometimes up to 5, 6 passwords which you used previously, and then they, they don't allow you to use the password. That's what we call password history. Then we do have a password policy. Password policy is what should be the length of the password, how often you must change your password, what kind of password combinations you use. All of these are considered, called a password policy, rules, regulations, how we use them. But however, we don't want everybody to use his own policy. Instead, there must be a centralized policy coming out of the central server, which we call the domain controller. In that case, we call it a group policy. It allows an administrator to configure a setting once in a group policy object on the central server, what we call Active Directory, and apply this setting to many users and computers within the domain. What is the impact? Everybody has identical group policy. If say password length is 14 characters, everybody uses 14 character. If passwords expire every 90 days, it expires every 90 days for everybody. So basically, it is very, very important. Additionally, administrators are the one who implement what we call domain group policy, which is on domain controllers. Domain controllers are the central servers for authentication purpose. They do a lot of things beyond authentication, but mainly they implement group policy. So the local group policy editor looks like this. If you go under computer configurations and under Windows setting, under security setting, you will see password policy. And on the password policy on the right side, you see enforce password history. How many passwords you want to remember? What is the maximum password age? It has to be, let's say, 42 days in my case. What is the minimum password age? What is password must meet what kind of complexity requirement? Do you want to store password using reversible encryption? Those are a policy. So this policy can be implemented on a local computer. Like I said earlier, we don't want to use a local policy unless we use it at our home. But the most important thing is policy comes from the central server and it overrides the local policy, and we will have a domain policy. That is the most important group policy. Then we do have what we call account lockout policy. This is another policy. That's a password policy. There's account lockout policy. There are different kinds of group policy. So this is one of the important policy because what we need is after how many attempts your password need to be locked. This is what we call account lockout threshold. This is the maximum number of times a user can enter the wrong password. They call it, they give you 3, 4, sometimes they give you 2. It depends on the system and the policy. Once you make 2 mistakes, then your account gets locked for a certain amount of time. That is what we call account lockout duration. This indicates how long an account remains locked. If the duration is set to 0, the account remains locked until an administrator unlocks it. So basically, that is one of the important policy in account administration. So there is something what we call in this meantime, before we proceed, we need to look into one of the common mistakes in monitoring and controlling our password, which is what we call a default password. Many devices in our home or in many appliances, they come with a default password and a default username. Let's consider, for example, the router, the Wi-Fi router in your house. It comes with a default username and a password. In most cases, most people, about 70% of the people from I found this on somewhere on a statistical study. 70% of the users, they don't change the username and the password. We do have cameras. We do have Wi-Fi cameras connected in our house. We don't change the default username and password. That's dangerous. So the first thing when you buy an appliance that comes with default username and password is change the password. At least change the password. Then, if possible, change the username, both username and password. Okay, let's proceed into the authentication factors. Among the authentication factors, the first one, or the simplest one, we said is was something you know, but something you have is also very, very important. So in something you know, we discussed about a password. In what we call something you have, we need to discuss about smart cards. What are smart cards? Those are a credit card sized cards that have an embedded microchips and a certificate. So there is a chips that contains data, and there is also a certificate embedded on the card that identifies that proves your identity. So what are the requirements? There are two requirements. So one is there must be a certificate, an embedded certificate. The certificate usually holds a user's private key, what we call a private key. A private key which is only accessible to the user, that's private mine, and it has to match the public key that is publicly available to others. The private key is used each time the user logs into the network. Okay, when you log on to a network, you have to use your private key. So what else do we need? In order to implement the authentication using a certificate, we need to have a PKI, a public key infrastructure. That is something that supports issuing and managing certificates is a must for us to use a smart card implementation. So the smart cards are classified into two. One of them are called, we call them a common access card. This is a specialized type of smart card used by the US Department of Defense. Particularly, these kind of cards include a photo picture, a picture of the card holder. So basically, when you try to access, it also verifies whether you are the right person or not through your picture. The second one is usually used by civilian organizations. It is called a PIV, personal identification or personal identity verification card. It is also another specialized card. It has smart chips. However, it doesn't hold your picture, or it holds less information compared to the common access card. Additionally, as part of something you have, sometimes we do carry what they call a token or a key fob. A few years ago, this was very popular. A company called RSA Secure ID was, predominantly, offering those cards as a way of authentication. So there is a display. On that LCD display, you see a number. That number changes every few seconds. So it synchronizes with the resource you are trying to authenticate. So unless the number on your card, on your what you call a token, or sometimes they call it a key fob, unless the number on the key fob matches the number on the resource you are trying to authenticate, it doesn't let you in. It gives you any kind of authentication. So this is also something you have. So something you have, at least we know that your card and your key fob, those two are things what we call something you have. Then comes what we call something you are, or in another terminology we call this biometric identity. A fingerprint scanner, which is common these days on your cell phone. A retina scanner scans the retina of either one or both of your eyes and it uses a pattern of the blood vessels at the back of the eye for recognition. So it is a newer technology. We also have what they call iris scanner. This is something that uses camera technology to capture the pattern of the iris around the people for some kind of recognition. We also have a voice recognition. Computers are smart these days to identify your voice. You speak in front of the computer and it lets you in. Also, there is facial recognition. That's very important. The geometrical pattern of your face, they can have some kind of mathematical calculation to use it as a password. This is also a very popular. Eventually, it's getting very popular. However, there is some error with this kind of biometric devices. Let's discuss those biometric errors. One of them is what they call a false acceptance. Sometimes it allows someone that should be prohibited. This is when the system incorrectly identifies an authorized user as the authorized user. Then we call it the false acceptance rate. There is a measurement. You do statistical study on the machine before you implement it. You let it test 1,000 users, and out of 1,000, how many of them are falsely accepted using somebody's, facial or biometric identification? The false rejection is sometimes, even if you are the right person, the device rejects the authorized user. That is what we call the false rejection rate, or they call it a false non-match rate. It identifies the percentage of times a false rejection occurs. If it happens a lot, that is a problem. So before you buy a biometric device, you must study the false rejection rate and the false acceptance rate. That's very important. Then comes what we call somewhere you are. The somewhere you are authentication factor identifies a user's location. So basically, there is a geolocation service. It is a group of technology used to identify a user's location, and it is the most common method. That is the geolocation. It tells you exactly where the user is trying to access the machine. If it is coming from China, it tells you, oh, this is from IP address located in China. He's not allowed to get into this system, and you will not be authenticated. So this is one of the most getting very popular. It gives more security. So somewhere you are is also one of the authentication factors. Then comes what we call something you do. The something you do authentication factor, it refers to actions you can take, such as gestures on a touch screen. If you are a user of those modern cell phones, you are familiar with the gesture. You put your finger like a Z or like an X, and then the screen identifies based on your gesture. It authenticates you to use that device. Other highly secured systems, they also use something called dwell time, which is the time the keyboard is pressed. How fast you are moving your fingers off the keyboard, or particularly when you get older, your fingers stick there and they don't come back, they don't pick up quickly. So there is a number, there is a mathematical calculation to let how fast a person is typing. If you are a typing student, they tell you your typing speed is 35, 36, 42, 45. So based on how fast you type on the keyboard, the system identifies who you are, and sometimes it locks the system. A suspicious user is sitting on the keyboard and it locks it. This is particularly very, very important when your other factors of authentication are compromised. This is one of the strongest way of stopping someone, an intruder, from not using your username, password, or any credential. Then finally, we will come to discuss what we call a dual factor and multi-factor authentication. So when we say a dual factor authentication, sometimes they call it two-factor authentication. What you are using is only two of the different authentication factors we discussed earlier. It could be something you know, which is a password, with a card, which is something you have. You are using something you know and something you have. It is two of them. It is a dual factor authentication. Or it could be your fingerprint, which is something you are, and something you know. It could be a password. Again, it is a dual factor authentication. When the number of authentication is more than two or more, we call it multi-factor authentication. Sometimes you use a password, your PIV card, and then on top of that you use your fingerprint. Now it is three, so it's not dual factor, it is two or more. We call it a multi-factor. Now let's look what kind of service is facilitating this kind of authentication. So we are getting into authentication services. The most popular authentication service is what we call Kerberos. It is a network authentication protocol. It's common, or it is probably most commonly you'll find it with the Microsoft Windows Active Directory domain. Remember when I mentioned earlier what an Active Directory is? That is the central authentication server. That's where we get, authenticated. That's where the group policy comes down to our computer. It also is available in what they call a Unix realm. It uses a database of objects such as Active Directory and KDC, or they call it TGT server. So the Active Directory issue time-stamped tickets that expire after a certain time period. So basically you grab your ticket, you take it to the resource, and the resource allows you access. So this is one of the authentication service common in the corporate world. The other one is what they call a new technology LAN manager. This is also a suite of protocols. It provides authentication, integrity, and confidentiality within a Windows system. This NTLM has multiple versions. They call it NLM, NTLM version 2 and NTLM 2. At most basic, they use what they call a message digest hashing algorithm to challenge users and check their credentials. In fact, the most basic one, the NLM, is already compromised. We don't use it anymore. We use NTLM version 2 and NTLM 2, but NTLM 2 is the strongest one. Another authentication services is what they call LDAP and LDAP-S. LDAP is a lightweight directory access protocol. Usually when you are far away from the central Active Directory, we use a lightweight directory access protocol to get connected to the directory services to get an authentication service. We also have directory objects and LDAP-S. LDAP-S is a secured LDAP connection protocol that is using TLS. So basically, these are the most common authentication services. As we continue into different kinds of authentication services, there are common terminologies we call SSO, which is a single sign-on, SAML, and federation. Single sign-on it refers to the ability of a user to log on or access multiple systems by providing credentials only once. That's wonderful. It increases security because the user only needs to remember one set of credentials and is less likely to write them down. If there are 5 different systems, you don't need to have 5 different username and 5 different password. it creates a lot of pressure on remembering all those 5 username and password. And instead, what it does is you just log in on one of the servers, then you'll be automatically be able to log into the other servers. So this is based on what they call a transitive trust. You need to understand this. What they call a transitive trust is it is an indirect trust relationship. For example, imagine a transitive trust relationship exists between me and my friend John, and then Paul. What happens is I trust John, John trusts Paul. So what happens between me and Paul? There is a transitive trust relationship. Even if I don't trust Paul directly, we do have a transitive trust relationship. This is the basic principle how single sign-on works. In the same way, there is what we call a federated database. This provides central authentication in a non-homogeneous environment, meaning the users are coming probably from different companies. They want to work together. Probably one is using a Unix environment, one is using a different kind of Active Directory, probably one is using another type of authentication service. Then the federated database creates a common database for all 3 companies to create a common environment out of a non-homogeneous environment. That's what we call federated database, and Shibboleth is one of the most popular software for federated database. Then comes what we call OAuth and OpenID Connect. The OAuth is it's an open standard for authorization. Many companies these days they use to provide secure access to their protected resources. But instead of creating a different account for each website you access, you sometimes can often use the same account that you have created, let's say with Google or with Facebook or with PayPal. So instead of telling you create a username and a password, they ask you use your PayPal username and password to authenticate to our system, or your Facebook. This is getting very popular and getting very common. So that is what we call an OAuth and OpenID Connect. It also works with the newer version of OAuth 2.0, and it allows clients to verify the identity of end users without managing their credentials. They don't want to manage your credential. It allows you users to sign in using their Facebook credential. So these are a newer way of credential services. It's coming very popular, and it's making things very easier. Then it comes here we need to look into 2 important concepts about authentication, what we call a list privilege and need to know. List privilege specifies that individuals, let's say a user and processes, you grant them some kind of rights and permission needed to perform exactly to enable them perform the assigned tasks. No more. Let's say a user is hired as a data entry person. His job is just to come in and to the computer, type and make data entries and go home. He doesn't need to be an administrator to that computer. There is no need. There is no need for that person to be an administrator. So that is what we call list privilege. And then there is another concept called need to know. Users are granted access only to the data and information that they need to know for their job. Notice that need to know is focused on data and information, which is typically protected with permissions. In contrast, the principle of list privilege includes both rights and permissions. So basically, unless someone has a need to know, he shouldn't be given a permission to access that resource. Then as part of authentication, we need to identify the common account types in a work environment. The most common one, or most accounts that are used by regular users, we call them end user accounts. Administrators create these accounts and then assign appropriate privileges based on the user's job responsibilities. Microsoft refers to this as, they call it a standard user account, but we call it an end user account. End users are at the end of the network sitting on a laptop or a basic computer to access servers. They don't have any other privilege to manage the network. Then we do have what we call privileged accounts. A privileged account has additional rights and privilege, which is beyond what a regular user has. For example, someone with administrator privilege on a Windows computer, he has a full and complete control over the Windows computer. He can install application. He can change some components of the computer. So basically, privileged accounts are with a more powerful rights. Then we do have what we call a guest account. Windows operating systems, by default, there is a guest account included. This guest account comes with a blank password. So basically, when you buy a computer, go into your system and disable the guest account. Someone can log into your computer, even if he doesn't access your files and other documents. He can have access to computers through a guest account. So guest accounts should be disabled. Then we do have what we call service accounts. This is very important. In a corporate environment, we create hundreds and hundreds of service accounts for different applications. For example, you have a SQL server. It is a database server, a database application. It runs on a server and it needs access to some resources on the server and the network. So basically what the administrator does is he creates a regular user account. He names it something like SQL Server Services, and then it assigns it appropriate privilege and configures SQL Server to use this account. Similarly, the mail server has another service account. Every application, about almost all applications need some kind of service account. So even on your desktop, these services are running in the background using some of the privilege from your computer without your knowledge. So basically, we do have end user account, privileged accounts, guest accounts, and service accounts. Those are the 4 common account types in a corporate environment or in a computer industry. All right, we just went over account types. Let's discuss about account controls. How do we control those accounts? A few points to discuss. Administrators must have 2 accounts. They do have a privileged administrator account. They use it when they are working their administrative duty. They use their end user account when they normally work on their computers. So basically, encourage administrators to have 2 accounts and to use them appropriately. And then there must be a standard naming convention. What is your username? Is it Kefseha, or is it Fkone, or is it F what? So there must be some kind of a naming convention. There must be a standard. That's very helpful. Also, prohibit shared and generic accounts. Don't create a single account and tell multiple people use the same account for different shifts. Even if you have 3 shifts in a day, don't use the same account. Don't let them share a single account. Let everybody has his own account, and don't use generic accounts like a guest, administrator, or anything. Also, you must have a policy on how to disable an account. When do we disable an account? Let's say an employee is terminated today. When do you disable his account? or when do you delete his account? There must be a policy. We don't delete it immediately because that employee might come back again after 2 weeks. Through some kind of, bargaining, he might, or the manager might give him a call and say, okay, come back to work. So don't be in a rush to delete someone's account when someone is terminated. Just disable it and wait for a while. The same way, when someone is on a vacation, on a leave of absence, disable his account. And also, when do we delete accounts? There must be a policy. After 3 months of inactivity, after 6 months of inactivity, after an employee is terminated for 2 weeks and he don't come back, there must be a policy, what we call it, disablement policies. Also, recovering accounts. How do we recover an account? Let's say you lost your password. You are at home and you want to access your computer from home to work. You pick up a phone and call help desk. Would you please reset my password? Here is my username. What's the policy for the help desk to reset the password? That's very, very important. That's a very important thing. We must be able to have a policy on how to recover account. Also, the time of day restriction. This is very important. Sometimes no one should access the corporate network after midnight. So the computer will be configured not to work after midnight. This is usually a group policy settings. Finally, we have to discuss what we call comparing access control models. We do have different type of access control models. The most common one is what they call role-based access control. You get hired into, a corporate environment or some kind of civilian organization. If you are an IT person, immediately they put your name under the IT group. Based on your role, you will inherit those role-based access controls. The other one is what they call rule-based access controls. This is commonly used for devices, firewalls, or some other, proxies. You get a permission, or you set a permission based on a rule. Let's say, for example, allow IP address this to go through the firewall and reach port number 25 on this specific server. So that's a rule. So you set up a rule and that rule will be implemented on the device. The other one is what they call discretionary access control. This is commonly used for files and folders. You go to your folder, right click on it, say property, it takes you to security. Under security, you can give read permission or write permission or full control permission. It is up to your discretion. It's up to your, you assign to whomever wants to get a specific access, you assign it based on that. Then we do have a mandatory access controls. These are particularly in a heavily secured environment where users, are classified based on their security clearance. So if there is a folder or if there is a resource, that resource is accessible based on your clearance level. The system is configured to identify your clearance level, and it is mandatory. Unless you have a specific, clearance level, unless you are, for example, a top secret clearance level, you can't access that folder. That's mandatory. No one can change it. This is particularly in a highly secured environment. Then we do have attribute-based access controls. This is a policy. You create a policy. Hey, this resource is available, or this printer is available for managers from accounting department who are this kind of level and who are sitting in this particular location. So that is an attribute. You create different kinds of attribute combinations to provide access. Then we do have two terminologies. We call a subject and we call an object. Subjects are typically, the users or groups that access an object. The subject, the user, accesses the object. Objects are the items, like the file, the folder, the printers, the shares. So these are what we call object. So users access files and folders, meaning the subject is accessing the object. At this point, we conclude our section for identity and access management, which is module 4 on the exam and on the book. Keep on reading further into the book and follow the additional exercises I'm providing. Ask questions, come to the class after watching this presentation and reading the book, and we'll continue additional exercise. Thank you. We are located at 5100 Leesburg Pike, Alexandria, Virginia. If you want to email us at training@bakapps.com. Thank you.